Our lesson on 6.5 is going to have us divide polynomials, and we're going to use two different methods. First, we're going to discuss long division, and then we're going to discuss a technique called synthetic division. And you need to know how to do both. So first, I want to remember how to do long division back when we were in 4th grade. So if I had 142 and we were trying to divide it by the number 3, well, we'd start by taking 3 and trying to divide it into the first couple digits. Well, 3 doesn't divide into 1, so we say 3 goes into 14 4 times. And then our next step was to multiply. 3 times 4 gives us a 12. And then our next step in 4th grade was to subtract. 14 minus 12 gave us a 2. Well, since 3 doesn't go into 2, the next thing we had to do was bring down the other digit, which is another 2. And then we do it all over again. So 3 divides into 22 7 times. 7 times 3 is 21. And then we would subtract. And there's nothing left to bring down, so unless we wanted to go into decimals, our 4th grade teacher would have us call this number right here the remainder. So in 4th grade, we would say our answer is 47 with a remainder of 1. So if you think about our steps, first we were supposed to divide, then we were supposed to multiply, then we were supposed to subtract, and then we brought down the next number, and then this cycle repeated until we ended up with a remainder. We're going to apply the same concept to polynomial division. So number 1 has x squared minus 5x plus 6 divided by x minus 3. So we're going to set this up just like a long division problem in 4th grade. X minus 3 goes outside of this little division symbol, and then the x squared minus 5x plus 6 goes inside the division symbol. So, instead of looking at this as an entire polynomial, you really just want to look at it from the first term. So we think about taking x and dividing it into x squared. Well, the other way to think about that is what times x would give me x squared, and that answer would be another x. So that's the division part, and now we're supposed to multiply. So we take our x and we multiply it by the quantity x minus 3. Well, that gives us x squared minus 3x. Well, then remember our next step is to subtract. So I'm going to put parentheses around that and a subtraction sign outside of it. When I take x squared minus x squared, those end up canceling. And then negative 5x minus a negative 3x is really negative 5x plus 3x, which is a negative 2x. We're going to go ahead and bring down the plus 6, and now we're going to start the process all over again. So I think about how many times x will divide into negative 2x, or in other words, what's negative 2x divided by x? And that answer is a minus 2. So that was the division part. Now we're going to multiply negative 2 times x minus 3. So negative 2 times the quantity x minus 3 gives us negative 2x. And then negative 2 times negative 3 is a plus 6. But remember, we're supposed to be subtracting this from the part above it. And we end up with nothing. 0 x's, and then 6 minus 6 is 0. So we have no remainder. So our answer is simply x minus 2. Okay, let's try the next problem. So the x plus 1 goes outside, and we're going to divide that into x squared plus 6x plus 2. So we're going to start with x divided into x squared. X goes into x squared x times. That's the division. Now we're going to multiply x times x plus 1. That gives us x squared plus x. And then remember, we're supposed to be subtracting these. So we get no x squareds, they cancel out. 6x minus 1x gives us a 5x. And we're going to bring down the plus 2. And then we divide all over again. So the x divides into 5x 5 times. So I'm going to say, whoops, I wanted that to be red. Plus 5. And then we're going to multiply 5 times x plus 1. So we get 5. Keep my colors straight. We get 5x plus 5. Okay, And then remember, we're supposed to be subtracting these. So now the 5x and the minus 5x will cancel, and then 2 minus 5 gives us a negative 3. Now we're done bringing anything down, there's nothing else we can do, so this guy right here is called our remainder. Now in Algebra 2, we can't just say x plus 5 with a remainder of negative 3. We have to actually write our answer out for what it represents. So our answer is an x plus 5, but then what we're going to do is we're going to add our remainder, and a remainder means that he's still technically in the middle of a division problem. So remember, this is being divided by the quantity x plus 1, which means your remainder is still technically being divided by x plus 1. So this is our answer, and the only other acceptable form of this answer that I would accept is if instead of saying plus a negative 3 over x plus 1, you could write it as x plus 5 and then just say minus 3 over x plus 1. So you could bring that negative down. So either one of these answers is great. Okay, our next example, x minus 1 out in front. Oops, that's a minus. And we've got 4x to the third minus 5x squared plus 2x and a minus 1. So this is going to be a couple extra steps, so write a little bit smaller. X goes into 4x to the third. Let's see, we'd have to multiply by a 4 and x squared in order to make that work. So 4x squared times x minus 1 gives us 4x to the third minus 4x squared. Now remember, we're supposed to be subtracting these. So the 4x to the thirds cancel. And negative 5x squared minus a negative 4x squared is really negative 5 plus 4. So we get a negative 1x squared. I'm going to go ahead and bring down the plus 2x. And then we're going to divide again. So x divides into negative x squared. Let's see, negative x times. Then if I go ahead and multiply those, negative x times x minus 1 gives me negative x squared plus x. And remember, we're supposed to subtract that. So the negative x squared plus an x squared would cancel. 2x minus 1x would give me an x. And then we still have this minus 1 I need to bring down. So x minus 1 is what's left here. X goes into x one time. And when I multiply that, I end up with x minus 1. And remember, we are subtracting it. So this is another case where we end up with no remainder. So our final answer to this problem was 4x squared minus x and then a plus 1. Alright, moving along. One more long division example. X plus 2 goes outside. Now we've got 3x to the third plus 2x squared plus x minus 4. So first, x goes into 3x to the third, 3x squared times. When I multiply those together, 3x squared times x plus 2, I get 3x to the third plus 6x squared. And now we're supposed to subtract those. 3x to the thirds will cancel. 2x squared minus 6x squared gives us a negative 4x squared. And then we're supposed to bring down this other plus x. So now when I look at negative 4x squared being divided by an x, that goes in negative 4x times. When I multiply negative 4x times x plus 2, I get a negative 4x squared and then a minus 8x. You're going to notice that if you do this and the first term doesn't cancel when you subtract, you did something kind of goofy. So you'd go back and fix that. So the negative 4x squared and the 4x squared will cancel. X minus a negative 8x would be x plus 8x, which is 9x. Then we still have this negative 4 to bring down. So 9x divided by x, that goes in 9 times. And when I multiply that, I get 9x plus 18. Whoops, I didn't want to make that red, did I? Oh, it's supposed to be green. So 9x plus 18. And then remember we are subtracting this. And that's going to leave us with no x's, but it's going to leave us with a negative 22. So that is our remainder. And we're going to have to write him as part of our answer. So our final answer is 3x squared minus 4x plus 9. And then if you want to put a plus and then a negative 22, your remainder, he's still technically being divided by the x plus 2. So that's a fine answer. If you want to switch out the plus, the negative for just a negative, that'd be fine too. So you could write it as 3x squared minus 4x plus 9, and then you could put a negative sign right here instead of in front of the 22. So both answers are great. I don't like one better than the other. They're both great. Alright, so that's long division. And it's not the worst thing you've seen, but it's not the greatest. So someone along the way decided that if we were doing long division with a linear expression, that it really wasn't that bad because they found a shortcut, and that shortcut is called synthetic division. Now synthetic means fake, so this is really just fake division. So what's going to happen is your setup has a little box, corner box here, and then a line. And what you're going to write here are going to be your coefficients. And then inside this box, you're going to write the solution to the divisor. And I'll show you what that means in just 1 second. So, right in this little box, we're going to write the solution to the divisor. Well, this guy right here is the divisor. So his solution would be if x equals 3. Meaning if I took x minus 3 and set it equal to 0, his solution would be positive 3. So that's what we write out in the little box. And then next to the box, we're going to write the coefficients of the first polynomial in standard form order. So his coefficients are 1, negative 2, negative 10, and a negative 15. So I'll just kind of take a minute and look at that setup and see if that makes sense to you. The solution to your divisor goes in the box, and then the coefficients go right along here. So our first step in synthetic division is always the same. You need to have a starting point. So you're actually going to bring down your first coefficient and write him right there. Once you do that, this becomes a series of multiplication problems followed by an addition problem. So we're going to multiply and then we're going to add. And we're going to do that until we get to the end. So our next step is we're going to take the 1 and we're going to multiply it by the 3. Well, 1 times 3, we're going to put our answer right here, is a 3. And then the addition is when I add up this column. So negative 2 plus 3 gives us a 1. And now we repeat that all over again. So 1 times 3 gives us another 3. And then when I add together this column, negative 10 plus 3, I get a negative 7. And then again, negative 7 times 3. This time gives me a negative 21. And when I add together this column, I get a negative 36. So what we just found are the coefficients to our answer. Now this last number that you got is going to be our remainder. And these guys here are the coefficients. So what we have to think about here is we had an x to the third and we divided it by an x to the first. And what would be left would be an x squared. So this first coefficient goes along with the 1x squared. And then after that, it's in standard form order. So 1x squared plus 1x, and then this last number is your constant term, minus 7. And then remember what we do with remainders is we write them as a fraction because they're still technically being divided. So the negative 36 over x minus 3. Now, most of you would never ever write the 1's as the coefficients, so most of you will be writing your answer like this: x squared plus x minus 7, And then same issue with the plus and the minus. You don't have to have both of them. You can just say minus 36 over x minus 3. That'd be a great answer right there. So the work on long division versus synthetic division, once you get the hang of synthetic division, most people agree it's a little easier than long division, particularly because you just have to multiply and add as opposed to divide and subtract. Most people do not like to divide and subtract. Let's try a few more examples. Okay, so the solution to the divisor, which is this guy, needs to go right here. So his solution would be a -6. And then the coefficients get lined up next. So a 1, followed by a -1, followed by a -42. And if you remember, our first step in doing this problem was to bring down the first coefficient. So if I bring down that first 1, I have a starting point. Now it's a bunch of multiply add. So we multiply 1 times -6, and that gives us a -6. And then we're going to add up this column. -1 plus -6 gives us a -7. And then we're going to repeat the process. -7 times -6 gives us a +42. And when I add up that column, I end up with no remainder. And now when this happens, just for a side note, because this is going to come up the next lesson, if you have no remainder, or if the remainder equals 0, then that divisor is actually a factor of that polynomial. And if you thought about trying to factor x squared minus x minus 42, x plus 6 is one of his factors. So my final answer, remember these are the coefficients to our answer, and if I took an x squared and divided by an x, that would leave me with an x, and then following that would be the constant -7. So your answer is x minus 7. Okay, the next example. Our solution to our divisor would be a -2. Now this is a little tricky. Remember, we have to put the coefficients in standard form order. So his first coefficient would be a 1. But do you notice that he seems to skip over, there's no x squared term? So it's kind of like there's 0 x squareds and there's 0 x's, and then it gets to the constant of -8. So you have to put zeros as placeholders to make sure you cover every single part of that polynomial, even if it's not written, because we don't normally write a 0. So our first step, once we have it set up, is to bring down the first coefficient, which is a 1. And then we are going to multiply, add, multiply, add, multiply, add. So 1 times -2 gives us a -2. And when I add up that column, I get a -2. And now I do it all over again. So -2 times -2 gives us a +4. And when I add up that column, I get a +4. Do it all over again. 4 times -2 gives us a -8. But be careful here, when you add up this column, they don't cancel. You get a -16. So that last number we have here is our remainder. And we got to think about how to write our answer. So if I took an x to the third and divided it by an x to the first, that would be x to the third divided by x to the first is x to the second. So this first coefficient goes along with my x squared term. And then continuing down the line, the -2 would be for the x to the first term, the +4 would be the constant, and then the remainder is a -16. He's still being divided. Remember, he was being divided by an x plus 2. So that is your final answer for number 7. Okay, another example. Solution to the divisor would be a -2, and then our coefficients go from a 2, let's see, x to the third, x squared, so 6. Notice there seems to be an x to the first term missing, so we're going to have to put a 0 placeholder there, and then a -9. I want to caution you, if this shows up on your homework, even if there's no constant, you still have to put a 0 for your constant as a placeholder. It's got to go all the way down to the constant term. Another way to think of it is whatever the degree is, you're going to have one more number than that in your coefficients. So if it was a degree of 4, something with a 4th power, you're going to end up with 5 coefficients in the lineup. Okay, bring down the 2. Whoops. and then it's a bunch of multiply, add, multiply, add, multiply, add. So 2 times negative 2 gives us the negative 4. When I add those together, I get another 2. 2 times negative 2 is a negative 4. When I add those together, I get a, negative 4. Negative 4 times negative 2 is a positive 8. When I add those together, I get a negative 1. So this last number that I got is going to be the remainder. And if I think about what I did originally in the problem, I took an x to the third and divided it by an x to the first. So this is going to be the x squared term, followed by the x to the first term, followed by the constant, and then our remainder is still being divided by the x plus 2. Okay. Alright, our next section is going to give you a polynomial, and it's going to give you one of the zeros of the polynomial. Well, remember, what that meant is if I went ahead and did either synthetic or long division, it would end up coming out with no remainder. So I don't know about you, but I'm liking synthetic division a little better. Since they gave me a solution as a 0, when I set this up, I'm just going to put that negative 2 in the box, and then the coefficients are going to trail after it. So 1, negative 5, negative 2, and then a 24. And then remember the setup says to go ahead and bring down the 1. 1 times negative 2 is negative 2. Add those together, you get a negative 7. Negative 7 times negative 2 is a 14. If I add those together, I get a 12. 12 times negative 2 is negative 24, and sure enough, no remainder. Now, the directions here said fully factor the given polynomial. So I'm going to write down what my answer is so far. Remember, I had x to the third divided by an x to the first. So this is x squared. So I'm left with x squared minus 7x plus 12. Well, they wanted me to fully factor this polynomial. And I'm thinking now that I'm down to quadratic, I can factor this pretty easily. X squared minus 7x plus 12 is going to factor into x minus 4 and x minus 3. So my final answer is not only the x minus 4 times the x minus 3, but remember, in the original part of the problem, they told you that x equals negative 2 was one of the answers for a 0. So if I switched him back into a factor, his factor would have been x plus 2. So this is the full factorization of the original polynomial. So the original factor of 0 with the additional 2 that I found at the end of the problem. So it's kind of working from another direction, but it's the same concept. Okay, another one of these examples. The solution, the 0, goes out in the box, so the 10 goes out here. Then we have our coefficients of 1, negative 12, 12, and 80. Now remember, since that's a 0, this should come out to a remainder of 0. So we bring down the 1, and then we multiply, add, multiply, add, multiply, add. So this is a 10. Add those together, I get a negative 2. We get a negative 20. If I add those together, I get a negative 8. Negative 8 times 10 is negative 80, and sure enough, I get 0 remainder. So if I go ahead and take this now quadratic and rewrite it in the algebra format, x squared minus 2x minus 8, and then I go ahead and I try to factor that, now that it's down to a quadratic, I end up with x minus 4 and x plus 2. So my final answer for this problem is not only the x minus 4 and the x plus 2, but remember, his original 0 of x equals 10 would have been his own factor, and that factor would have been x minus 10. There you go. The reason this technique is helpful is because we don't have any sort of tools in our Algebra 2 arsenal that'll factor this for you. I mean, you know, you can try some things like factor by grouping, but it's not going to work so hot for you. So we need to come up with another method, and this is the method that we choose to use in Algebra 2. Alright, now, same kind of idea. I'm still going to give you a polynomial, and I'm going to give you one of the zeros, but instead of having you find the fully factored form of the polynomial, this time I just want you to find all of the roots, or all of the zeros. So our answers are just going to be all of the solutions to the factors. So setup is the same. The 0 solution goes right here, so the -5. Our coefficients are 1, -1, -21, and a 45. And remember, since they said this is one of the zeros, you should get a remainder of 0. So 1 times -5 is -5. Add those together, you get a -6. -6 times -5 is 30. Add those together, you get a 9. -5 times 9 is -45. And sure enough, we get a 0. So now, since they want my roots or my solutions, now, whoops, back up. Not only do I need to write this as a quadratic and factor it, I'm going to have to write the solutions to the quadratic, which is not a big deal. We've done this before. So we're actually going to set them equal to 0. So if I try to factor x squared minus 6x plus 9, it factors into x minus 3 times x minus 3. So we end up with, the first solution was x equals -5, they gave us that one. And then another solution is x equals 3, but you'll notice he shows up twice. So I think we haven't learned about multiplicity yet, but write a little note to yourself that says multiplicity of 2. What that tells your reader is that the solution of x equals 3 shows up twice, and in the next couple lessons I'll show you what this looks like on a graph, because he even looks special when it has multiplicity. Alright, and I think that was our last problem. So we are done. 10, 11. I'm thinking, yep, that was it. Sorry about that. Alright, continue this lesson through your homework. It's probably broken up into 2 days. If you have trouble, please do come in and see me. This is a tough one.